Good morning, everyone, and welcome to the Algorithms and Data Structures Lab. We will do the actual lecture online later today, and I'll say more about the lecture later, but we are starting with the lab. So this course is offered in various degree programs, German language, English language degree programs. So we'll do the lab and the lecture in English, but you're obviously most welcome to ask questions in German. I'll say more about the course later, but one book I'll be referring to a few times is the Data Structures and Algorithms book in Python, published by Goodrich. If you want to read that book, you don't need to buy it. We have it available in our library as an ebook, and you can access it through our online library. And I have put a link for that in iLearn. So you don't need to buy the book. And there are a couple of other books, but I'll talk about this in a lecture when we talk about the actual course. So we have every Friday 4 lab sessions. Today we only have one because we are starting with Python. And sorry for having moved that date 1 or 2 days or the hour 1 or 2 days ago because there's a conference in parallel and the conference was shifted. So I also had to move this lab session a little bit today. But as of next week, we will have 4 lab sessions to work on the coursework. And I will also say more about the coursework in the lecture. Who of you has programmed in Python before? Maybe just raise your hand. So some have. Any other languages you have learned? Probably Java or C++ in your first semester. And the great news is Python is super easy to learn, and you will definitely not struggle learning Python. And also, this lab session and all the lectures are being recorded, and I put this on YouTube. So if you have any questions and you don't want to be recorded, just send it to the chat. The other lab sessions will not be recorded because the other lab sessions are just for your discussion, for any questions you may have on the coursework. So we're just recording this intro to Python and the actual lectures. So why do we use Python in this course? This course is not much about programming. The course is about algorithms and data structures. Yet, we should not just study theory, but actually build things that work and do experiments. So it's helpful if we are able to program the kind of algorithms and data structures we discuss. Why Python? Python is very easy to learn, and we have all of you from various degree programs. We have exchange students taking this course and many others. And Python is a very high-level programming language that everyone can learn quite quickly. And many of you study AI, and if you look at typical machine learning libraries, most of them are available in Python too. So it's helpful if you learn Python in the course of your studies. And some of you have studied Java before, some C++. So learning Python will be straightforward. And when I started here as a professor 5 years ago, and I started preparing this course, I was also surprised about how easily a lot of common algorithms and data structures can be implemented. Because when I was a student, that course was in C++, and C++ is really cool, but it takes you more time, but probably you can learn a little bit more about the underlying things that happen in your operating system or your computer because you need to deal with memory management. But the course that I studied when I was a computer science student, the lecture was 4 hours per week and not 2 hours per week. So we're a little bit time limited. And for this, we can easily implement the algorithms in Python. It's very high level, and we don't need to bother too much with the actual underlying architecture as you may need to do in C++. Are you all familiar with the term pseudocode? Who has heard about pseudocode before? Raise your hand. Some have not. So pseudocode means you just write some code on a whiteboard or a piece of paper. It's just a draft of your algorithm. But it's not an actual code that you can run because it's on a whiteboard, on a piece of paper or whatever. And the great thing is Python looks like pseudocode, but it can be executed. Yet you need to follow the grammar, obviously, but a friend of mine told me many years ago, Python is like pseudocode that can be executed. And this is not a programming course, it's an algorithms course. So if we can study the algorithms, the theory, and we can easily implement it, that's quite helpful. And as I said, Python is very popular in the data science world. And Python is an interpreted language. So if you have, for example, studied C++ before or Java, you would first compile your code into some other format like a bytecode or binary code, which will then be run on your computer. With Java, it would be run by the interpreter. And Python typically is not compiled, it's an interpreted language. So there's no compiler in between. Sometimes there is some compilation just in order to speed it up, but it's actually an interpreted language. And Python is a little bit different to what you have learned in Java and C++. Have you ever heard about strongly or weakly typed language or statically or dynamically typed languages? Who has heard that classification before? Maybe raise your hand, just curious. Okay, most have not, and so I'll discuss it. So strongly typed means that the programming language enforces strictness of types. For example, that you cannot just multiply a string with some other strange object. So you need to enforce types. Sometimes you can combine types like, I don't know, multiplying an integer with a float value or something like this. And you have seen Java or C++, those languages are strongly typed, and Python is also strongly typed. But if you look at Java or C++, those languages are statically typed. Like you create a variable A and you define its type, like an int, and then you cannot just suddenly assign a string to it. But Python is different. Python is dynamically typed, so you can change the type of variables throughout your runtime. This allows us to write some code extremely simple, but it can create new problems that your code may produce some errors or have some bugs that you just couldn't expect. But there are ways to address this. How do you get started with Python? So we are doing today this Python programming introduction. Who of you has Python installed on your local machine already? Okay, almost everyone. Nowadays, Python 3.x is the distribution being used, where X keeps growing for new versions. In the past, Python 2.x was popular, but that's pretty much outdated. So we use Python 3, and you need to install this on your computer. If you have not done this, you can either go to the Python website to install it from there. And there are other distributions. I personally like Anaconda to install it. Has any of you picked Anaconda when installing? So, okay, how have you installed Python then, from the Python website or? Sorry? Through PyCharm, okay? So and this again will cause some confusion if you're new to the Python world. You're able to install multiple distributions on your computer, and then you actually need to be using the right one from your IDE or from your terminal. So this may lead to some confusion. I personally like the Anaconda. It's a package management system with certain advantages, but this doesn't matter for now. And then there are lots of IDEs for Python. I personally like PyCharm, but you can also use Visual Studio or others. So this is totally up to you. Has anyone installed PyCharm? Okay, Visual Studio, maybe actually majority. It's up to you which IDE you use. There's Eclipse with Python extensions and so forth. And we will now have the intro to Python. And if you look into the Nextcloud directory of our course, you will notice there is a resources file, resources.zip, with lots of code snippets. And in there is an intro to Python file. And you can open the intro to Python file, and I have put it in my PyCharm, and it looks something like this. We will discuss this now step by step. And in PyCharm, once your PyCharm is set up and linked to the Python distribution, you can just click right and say run this file, and you'll see down here the output. We will discuss this file now step by step, but Python comes with one great advantage. You can run this .py file in batch, so you just click on run and it's run through. But Python also offers interactive programming. Has any of you done interactive programming before or heard about this term? So this seems to be the new one. And one hand raised, that's good. And that's why I will not be using my PyCharm, but actually I'll be using my terminal for today. You don't need to be an expert in using the terminal, but once you have installed Python, you should ideally have IPython installed already, or you need to install it. You can also run Python in an interactive mode by calling Python with the -i parameter, and then Python runs in an interactive mode. And interactive means you're not running the whole file in batch, but rather you're executing one line, and then you're executing another line, but your interpreter has not terminated. This is something that you're not able to do in C++ or Java because these languages are compiled. But here we can use an interactive mode. It exists with some other languages too. And for example, if you call python.-i, we see it's in the interactive mode, and I can just say I have a variable a and I assign the value 5 to it. We don't define types. We'll see this soon. And then I can run another line and maybe update a. And the interpreter has not terminated. And this interactive mode is really cool to learn programming. Plus, if you build some complex algorithm, you have probably tried this in your first semester, you run your code, it doesn't work, you make a change, you run it over and over again until you hope it works, so you try to debug it. So debugging is a little bit like an interactive mode in which you can run one line after another, but you cannot amend it much anymore. And here, the interactive mode is very helpful if you build a new algorithm, because you can try out something. If it didn't work, you just try out something new, and you just preserve the state of your program, and you don't need to run it over and over again from scratch. So the python.-i works, but better is IPython. And IPython is a little bit more advanced than the interactive mode of Python. Has any of you ever heard about Jupyter notebooks? Yeah, so Jupyter notebooks are the same thing, but runs in the browser. Feel free to also use Jupyter if you wish. In the past, IPython existed and the Jupyter notebooks came in later. The Jupyter notebooks are helpful because you can also visualize stuff and try out some other stuff. Feel free to do this on your own, but I'll be using now the interactive Python mode in IPython. And I'll show you some examples how to use Python. We'll have some time to discuss your questions. And we can now just create a variable a, and I assign value 2 to it. What we see is I don't need to define any type. The type gets assigned automatically because it's an integer. And if you wonder about the type, you could just call a function type. It's a native function, built-in function. It comes with Python. And you can say, what's the type of A? And the type of A is an int. If I now change the type of A, so I say A is value 2.3, then we see the type of A has changed to a float. So this is the dynamic typing. This is something you would not be able to do in C++, for example, or Java. what we've also seen is I call type of A, or I just type in A and I get an output. This output is only shown in the interactive environment. If you run a script, say in PyCharm, and you just run the script and you put A there, it will not be printed out. In order to print out something on the command line, you need to call function print and pass what you want to print, and then it appears in the actual output. So if you just type of A or A, all you see is the output in the interactive environment, but not the output on the terminal. So if you build some script and you write type of A and you wonder it doesn't show you anything, you need to write print of type of A. So this is a typical confusion in one of the early labs. Are you all okay with up to here? Good. Now I'll show you just a few basic things we can do in Python. For example, we will build a function. We can say we have a function that we call at3. Can you all read this well in the RIA, or is this difficult? Yeah. Is it just the blue that you cannot read, or? Yeah. So I don't really know how to change the coloring here. But anyway, the ones online can read it well, but I agree this blue doesn't look too great. So I write def, and def means I define a new function. And the name of my function is at3. And this function, and you find this in the intro to Python file, the add3 function I want to use to add 3 numbers. So I define 3 parameters, which are A, B, and C. And again, I don't define types here. This will all be determined via or when it runs during runtime. I don't define the type in advance. And in Java or C++, when you define a function, you would define the types, and then for the actual body of your function, or you would speak about a method, when you define the method in Java, you would use these curly braces to build the block. In Python, we don't build blocks with curly braces, but rather we put a colon here, and then we indent all of this. So we use 4 spaces to indent a new block. We don't use curly braces. This is confusing when you do it for the first time, but believe me, soon you will love it because it actually looks much cleaner. And now what I'm saying is I want to return A plus B plus C. This is my function. I also don't define a return type. It's all determined via runtime. And we can test this now. I can call at3 and I say I have a 4, a 2, and a 10. What's the output? And I don't put a print because I just use the interactive mode here. And we see the output is 16. So it's determined during runtime that I'm putting integers in here. But I can combine this with integers and floats. So I have a 4, a 2, and a 10.3. And then my result is 16.3. Do you have any other ideas what we could try to put in our add3 function? What kind of types? Strings, yes, let's try this. So we could say hello world and something like this. And we see it also works because the plus is overloaded here for concatenating strings. So this works. And we see it's fairly easy to build functions. The only thing that is new to you, we don't need types when we define it, and we don't use curly braces, but rather we indent. And we could also now build a condition. We could say, well, we define A again and say A is 3, and then I could say, can you all see in the rear still the bottom, or shall I move it a bit up? So all seem to be fine. Just this. And then I could say if A is 3, then I'll do something. I could print out correct. I could leave the if like this, so it would be just an if, but I can also add an else. And for the else, I could print out not correct, for example. And I type this, and once I have finished typing my if-else clause, it will be executed, and the output, I actually have this annotate here. Let's move it. Now the output is correct. So you see, this is how I build blocks. For students that are new to Python, sometimes they just don't know why their code doesn't behave as they expected. Make sure you indent correctly, especially if you have blocks within blocks, or you have an if within a loop or something. Pay attention that for each new block you indent correctly, because if you don't, then the code will not behave as you expected. So this is a little bit of a challenge, but once you have learned this and you're comfortable with blocks and indenting, then it actually looks quite clean. And you can build more complex ifs. You could build like an if and then an else if. In Python, you don't write else if, you write elif. You could say for and then print out whatever. And you can add more else ifs and so forth. And you don't have to put an else if you have an if there. You could also just have an if. So this is actually quite similar to Java or C++. The syntax is just slightly different. Any questions up to here? Then we have actually learned already lots of important stuff. We will now look at some fundamental data structures. So this course is all about algorithms and data structures. So we will learn in the next 3 months how to build fundamental data structures like lists or trees or hash tables on our own. But a lot of these data structures are available in Python already by default. When you use, for example, Java, have you used the array list class? Has anyone? Okay, and you use these classes, these data structures, by first of all importing them, and then you create objects. The good thing is in Python, all of this is much simpler because some of these basic data structures are part of the syntax. They're integrated into the language. For example, we can create a list, which I call L1, and I'm putting something in that list, say integers, 1, 2, 4, 8, 16. And all I need to do is assign a name to it, which is L1. And then this is my list with values 1, 2, 4, 8, and 16. Can everyone actually read these digits, or shall I make it bigger? Okay, we will try to make it bigger. Just need to figure out where I can do this. Yeah, well. Okay, Command plus, because somehow it's not getting bigger. Let's try this. Okay, thank you. Does it look better now for the ones in the rear? Okay, good. Perfect. And what we have created here is actually not an array as you would build in Java or C++. It's actually a list. In one of the next few lectures, we'll look at the difference. What's a list what's an array. But the good thing is we have very strong data structures integrated in this language. Now, we can also print this list. We can print L1 and we see what's in. And when you create such lists, say in Java or C++, all the elements need to be of the same type, also with an array, right? You cannot just mix in a lot of languages, integers, strings, whatever. And the good news is in Python, you can. We can say, well, we put in an integer, we put in a string, we put in a sublist, and then an empty sublist, and I can combine elements of lots of different types in these data structures. Something that does not work in a lot of other languages. We can print L2, we see what's actually in. If you need to know the length, how many elements are in a data structure, in a lot of languages like Java or C++, you need to call some method and say the data structure dot length or dot size, whatever. In Python, it's different. There's the len function that comes natively with Python, and you call this on your data structure. So you say, what's the length of L2? And we see there are 4 elements in. It's 4 elements because we have the integer, we have a string, we have a sublist with 2 elements, but it just counts that it's a sublist, and we have an empty sublist which also counts. So that's why there are 4 elements in, and we don't sum up that there are more elements in the sub-elements. We just count each sub-element as 1. Now we can also iterate over a data structure like this. And this, again, becomes super easy in Python. I can say for E for element in L2. So I have a for each loop. And what it does is it goes through L2 and in each iteration assigns the next element to variable E. And I could just print E and on a new line. So I first print a 1, then the test string, then the sublist, and then the empty sublist, and so forth. So it's all super clean, super simple syntax that should be super easy to learn. There is something that is a little bit more complex in Python. It's if I want to use indexes. So, because this is my for each loop, but I may want to also use an index and say, I want to index element 0, element 1. I can do this. I can say L2. I can access this at index 0, and I get the 1. I can index it at index 1, and so forth, at index 2, at index 3. And if I use an invalid index like 5, then I'll get an exception. But I can also use negative indexes, and they are valid. I can say L2 at index -1, it's actually the rightmost element. So this was my list, and index -1 would be that element, and index -2 would be that element. So this is sometimes quite helpful if you need to access the last element or something, you just use a negative index. And I can try to go through these indexes in a loop as well. I can say for my index I in something that we will look at very soon, I could print my list 2 at index I. And somehow I need to find a scheme now that generates me all these valid indexes. In Java, you would have a loop where you define your variable I with some initial value, how it increases, and some condition when it would stop. In Python, this looks a little bit different, and I'll type it first, and then I will show you what that actually means. I will type the range of the length of L2. We've seen the length of L2 before, that's 4. And what does this range do? We first run it and see if it actually works. I forgot the parenthesis. So it works as expected, which we print out the element with index 0, then index 1, index 2, index 3. The only question is, what does this one do? We've seen the length of L2, but what is the range of lengths of L2? If I run this, I don't get much out of it. It says it's the range of 0 to 4. Technically speaking, this is a so-called generator. That's a concept we will discuss in the midst of this lecture in a couple of weeks. The range here is an object that gives me all the integers from 0 up to 4, but it's an asymmetric boundary, so the 4 is not included. So this range here gives me a 0, a 1, a 2, and a 3. But if I print it out, say I print a range of 0 to 4, I still get nothing because it's a so-called generator and I need to convert this generator to a list. This is a concept we will see in a couple of weeks. For now, just trust me that the range of 0 to 4 would give me something like this. It's the integer 0, 1, 2, and 3. And in fact, if you say the range of 0 to 4 or the range of 4, it's just the same because if you don't define the lower boundary, it's 0 by default. That's why up here, we only wrote the range of that length and we didn't say it starts at 0. You can obviously say start at 2, end at whatever. And there's another parameter to customize the range, but this is something we can look up later. And now, since we have built this loop before, we actually see why it works, because the I runs from 0 up to 4, where 4 is excluded. So indexes 0, 1, 2, and 3, we actually get these indexes and print it out. Are you all okay up to here, or any questions? Then there's one more data structure that is super important in Python. It's a dictionary, or sometimes called a map. Has any of you ever heard about such a data structure? Dictionary, map, or hash table? Okay. What is it? What does the data structure do? For one of you who raised a hand.
Store key value pairs on the dictionary.
That's correct. So I store key value pairs. So I have a key and a corresponding value, and I can later access the data structure with the key and it returns me the value, or I can manipulate the value, whatever. And this is something that exists in Java or C++, but you need to include some library that implements this for you. In this course, towards the end of the course, we will also see how we can build our own dictionaries. But today, we will simply use the one that is available in Python by default. And these dictionaries are actually created with our curly braces. And the key value pair looks like this. I type the key. So I'll make it a bit bigger. The key comes first, then a colon, and then the value. And we could, for example, now build a key value pair where the key is an integer and the value is a string. And we could do this as well for the next pair, so 1 and 2. And we have just defined the dictionary. And I can now use the key, for example, key of 1, and it returns me the value. So I say, key is 1, what's the corresponding value? I can try this for the 2 as well. if I call it for a key that does not exist, I'll get an exception. And I can also manipulate this. I can say, for example, key 2 exists, but I want to change the string. For example, I write 2 in capitals. And if I then look at what's in D, I see the value was overwritten. Like this, I can also add new key value pairs. For example, D of 3, which doesn't exist. But if I write it this way, I say D of 3 is 3 as a string, then it's actually added to my dictionary D. So all fairly easy, actually. Super simple syntax in Python. And some of you said you know this data structure. In which languages have you used such data structures? Yeah? You raised your hand? Yeah. In which languages? Okay. If you use it in Java or C++, it's more complex from the syntax, and you have all this boilerplate code calling methods. Here, it's probably as easy as it can get. And remember, if you use if you write a Python script, don't just write D, you actually need to print out D, and then it appears on the terminal. And when we look at our intro to Python file, this is exactly what we have done. So far, we have looked into conditions, into types, how to build functions. There's a little bit more here about loops, but just some other examples. There's another loop in Python. It's a while loop. Works like the while loop in Java or C++. Feel free to look up the whole intro to Python file if you wish. And we've just looked at the dictionaries. So this looks all fairly easy. And we're already half done with our intro to Python. There's one tiny concept we will briefly look at. And then we look at object orientation, so how to build classes in Python. Now, I'll create a new Python file, which I just call test2.py. And I just write a very simple script. I can say A is 5, and I want to know if A is actually 5. And if so, I print out correct. Otherwise, I print out incorrect. Fairly simple. And I'll just run it, and it prints out correct. The only thing that we have to add now is something. You should never have Python scripts, at least for bigger projects, in which you type your code directly in the script like this. Because this Python file may be imported by other Python files. Imports is something we'll see later in this course, because maybe there are now some functions, there's some code in this Python file that some other file will need. So it will need to import this. And when you import a different module or a different file, some part of it actually gets executed. And we don't want to execute that code and have some printouts just because that file gets imported by some other file. Doesn't sound good, right? So what we need to do is something like, looks a bit cryptical. We would say if __ name is equal to a string that is __ main _. I did not come up with this. This is in Python, and what this says is, if the context in which I'm running the file is main, and that means if I run the file on purpose, this code gets executed. But this code does not get executed if this file gets imported by a different file. For your small toy examples here in the coursework, you probably don't need this one. But when you work on bigger projects, this may be important because it could happen otherwise that some of your code gets executed just because the file gets imported by other files. Something you can also do is obviously, you can say this is a function which I call function 1. Like this, it's also absolutely fine because this function will be imported when your file will be imported by a different one, but the actual inner part of the function will not be run. And obviously no parentheses. Sorry, yes, there are, sorry, yes, but with no parameters. So this function will be imported by other files, but it will not be run. But if I now click on run, it's also not being run. So what I can do is I can just type in function 1, and I'm running function 1. But this line will be executed if your file is imported by a different file. So what I'm doing is something like this. I'm just picking my name that is in the main context, and then I'm running function 1. So this is maybe a new concept if you haven't done Python before. It's probably not too relevant for your first few experiments with Python because you're not importing this in a different one. But I just wanted to mention it. And at some point later in this course, you'll have to come back to this. But it's also explained extremely well in the book. Mentioning the book, the Goodrich book. So all the stuff I've just shown you, these key sections of the intro to Python is also here. You're supposed to read a little bit more for further reading in this book on the weekend until next week's session. So the Goodrich book that I mentioned, the data structures and algorithms in Python. So it's this book here on the left, and it's available through our library as an ebook, so you don't need to buy it. There are a few chapters you are absolutely recommended to read. It's chapters 1.1 to 1.5 and chapters 1.9 to 1.11. Just to emphasize a little bit what I have just shown you with some more explanations, some more examples. But this is something you can read fairly easy on the weekend. Any questions up to here, or you're all good? Shall we continue, or you want a 5-minute break? Yes. Where to find this Goodrich book? I have the link to this in the iLearn course, and you just click on the link in the iLearn course and you get routed to our library. But this only works from campus. If you're at home, you need a VPN connection. Anyone has opened the ebook already? No one yet? Okay, but okay, one person, so you'll find this. There was another hand raised. Yes? It's up to you. I mean, you can pick any IDE you want. I personally like PyCharm. Others use Visual Studio. It's your choice. And yeah, the book is great. I bought the book, but I think it's quite expensive. So the ebook is accessible, and there may be other sources where you can find the book too, maybe a second-hand book, whatever. And be sure to get the right one from Goodrich, because Goodrich wrote a lot of data structures and algorithm books in different languages, but we use the Python one. But again, this is not a Python course, so if you take a different lecture, maybe Programming 2, some of my colleagues who teach Programming 2, they teach Python more in depth. I also taught the Programming 2 lecture in the past. We discussed Python in greater detail. So in this course, we will not be using all the tricks and tweaks in Python. We just use Python as a tool to build algorithms and data structures and study how they actually work. Has Programming 2 already started in your program? Which language is it? Python. Okay. And who teaches programming 2 right now? Evander or Jillich? Holger Jillich. Okay. Good. Then, yeah, he just started, so hope you have a good start with him. I taught programming 2 in the cybersecurity bachelor's a few years ago, and the slides are the same style like this slide, and I shared it with some colleagues who then taught programming 2. So maybe at some point you see my programming 2 slides that someone amended again. But I designed that programming 2 course a few years ago. But then I wanted to focus more on AI courses and only teach one foundation course. And personally, I find the algorithms and data structures course more interesting than the programming 2 course. So I kept that one and find it more challenging. But feel free to read the book, or not just feel free, actually, you're supposed to do this to understand these concepts a little bit better. And now we will continue with an intro to Python, and we will actually see that building classes and objects is fairly easy. You all learned about object orientation in your first semester in programming 1 in Java or C++, right? Anyone here who is not familiar with classes and objects? Good, everyone is familiar. Then this will be fairly easy now. So I'll define a class that I call base. Fairly simple syntax, just class base, colon, and then indent correctly. And now I need something that looks a little bit cryptic, but I'll show you what that means. I have this very ugly name, underscore, underscore, init, underscore, underscore. I didn't come up with this, but this would be the initializer. So something that is more or less the equivalent to the constructor, you know, in C++ or Java. And this one creates your object. And we need to pass one parameter arg, but we also defined a parameter self that is highlighted in green. And our self is something like the this in Java or C++. But when you write your constructor in Java or C++, you just put here the name of your class and the parameter, and that this is just there. You don't need to define it, right? In Python, you need to put the self there. Self is the equivalent of this, and you need to put it there so you actually have a method that has object context. You can also build functions without object context, with class context. So abstract one, not abstract ones, but static ones. But this is something that doesn't matter for now. But when you write methods, so something that has object context, don't forget the self, otherwise you will run into strange errors and don't see what it is. But if you run into strange errors, probably just check that your self is there. And now I have this parameter arg, and I want to store it in an attribute. So an attribute is a variable in my object. In Java and C++, you need to define in the beginning or at the end of the class your attributes. In Python, you don't need to define your attributes. Rather, you create them on the fly. So I can say self.arg is arg. So I'm creating a new attribute, arg, with context in the object, and I assign my arg value to it. So all much simpler than in Java or C++. Do you wonder if anything is missing here? If you looked at this from your Java or C++ world. We don't define types, but something else may be missing. Something that you need to put there. Louder? No, not two dots at the end. It's accessibility, if it's private or public. The thing is, everything is public in Python by default. And privacy doesn't really exist. There are some ways to declare stuff private, but it's still public. So if you want your attribute to be private, a convention in Python is you put an underscore at the beginning of the attribute, but it's still not private. It can still be accessed from outside. So it's just a convention. But we leave this convention for now because it's just the intro. So this is something that you need to pay attention to. And now we see we actually have two blocks within each other. We have the class, we have the constructor. So always make sure all of this is indented correctly, because if it's not indented correctly, so you have these 4 spaces missing here, then it will certainly not work. You will have some, in this case, a syntax error, but sometimes you don't have a syntax error, but the stuff just doesn't work as expected. We will also add a method, and we call this method math, and we actually pass another parameter, arc. Because it's a method, we need to define the object context again, so our self, and math will return our arc attribute, and we add the arc on top of here. We can also just call this arc1. Maybe not a great naming convention, but this is not a software engineering course. So what we are doing is we are returning the value of the attribute arc plus adding arc on top. But I don't need to call this arc1. I can also just write arc, and it's 2 different entities, because this one here is the attribute and this is the parameter I passed. So now we have our class built. Let's create some objects. We can create an object B, and we initialize the base, and we need to pass 1 parameter for the initialization, because if I did something like this, I'll get an error because I'm required to pass the arc. I don't need to pass the self. This gets created automatically, but I need to add or pass a parameter for arc, which is my base. And I can now run this method with 2 as a parameter, and then 3 plus 2 get added, and I get 5. So do you think this looks fairly simple, how to create classes in Python? Almost as easy as it can be. But everything is private. Everything is public. Don't forget that. Quite different to the Java world. Who of you has done inheritance before? Who has never done inheritance? Okay. So I'll briefly explain what it is. So now we have a class, and we can create objects. Not just one, we can create many objects. But maybe we want to have another class that is like our class, but with some specialization. So you could think about, you have a very generic class like car, and then, or say, yeah, maybe not car, you could say vehicle. And then we have more concrete vehicles like car, a truck, whatever, which are all separate, and you need to create objects of them. Yet a car may have some more additional properties than just a vehicle, and a truck may have the same stuff in common with a vehicle, but some other specialization. And that's inheritance. So you have a base class, and then you have derived classes. A derived class inherits from the base class, but adds some more functionality. And this is something we will also need in this course. For example, when we build hash tables, we start with a very generic data structure, and then we create more specialized hash tables that work in different ways. They all have something in common, but they vary a bit on how they are exactly implemented and how they deal with certain challenges. That's why it would make sense to have a superclass, the base class for hash table, and then maybe more concrete ones as classes. And now inheritance, again, is super easy in Python. I built a class derived and it inherits from base. So I just put parentheses there and base. I'll create a new constructor. And for my derived, I have a slightly different constructor because this one will have 2 parameters. And what I want to do is now, I have 2 args, arg1 and arg2. So I need to store arg2. And I'm asking you, what is happening with arg1 right now? We need to make a connection to the constructor of the superclass, because the superclass already knows how to handle the first parameter. So we can do that. And this is unfortunately a little bit cryptic in Python. Again, I didn't come up with this. I need to call the super context, super as a function, and call the constructor there with my arg1. And the constructor in the superclass takes care of this argument or that gets stored as an attribute. We can add a new function, math2, in which we pass an argument, and math2 will actually take our self.arg. Self.arg is the attribute that was created by the superclass constructor. We take arg2, which was created by our constructor, and we add arg on top. And we can test this briefly. And we can create an object of derived, say values 2 and 3. And then we can call math2 and add a 5. And then we'll get a 10. And we actually see here, we not just have math2, but we still have our actual math from before. So we can say this is 10, and then 10 plus 2 is 12, because our math only takes the arg, which we inherited from the base class. Yeah.
Function math2, can I write self.arg1 as well?
Like if I put self.arg1 here, this will not work because arg1 was only a parameter name. The parameter was passed to the superclass constructor, which stored it as the arg attribute. So if I put arg1 here, it will lead to an error. Yeah.
So how would that work amongst like multiple derived classes? So if I have another derived class from a derived class, do I call to the base function, or do I call to the first layer?
Depending on what you do, but typically probably the immediate layer above it, the actual derived first class and then derived second. In some languages, you also have strange stuff like multi-inheritance, that one class can inherit from other classes. It's something you may see from time to time, but it's nothing we need here in this course, because multi-inheritance leads to lots of new problems. So we're not doing multi-inheritance. But obviously we can have deeper inheritance hierarchies, that the one inherits from the other, inherits from another. But multi-inheritance would be that one class inherits from multiple classes at the same time. So this was the intro to our Python syntax. You're absolutely encouraged to use this interactive environment, IPython, but you can use Jupyter in the browser. You can test also PyCharm or Visual Studio. If you use something like this, then you have the advantage to also use a debugger. Who has never used a debugger? Okay. A debugger allows us to run a script line by line. And what you can do here on the left is you can put some so-called breakpoints. And when you run test 2 in the debug mode, it will run up to our breakpoint. And at the breakpoint, it will stop. And you could, for example, say, well, I do one step, and you always see the current state of your variables. You could also try to manipulate them. You could skip a function or just step over a function. You could step into a function that gets called. So a debugger is very helpful to understand problems if your code does not work as expected. What you should never do is add all these print statements to your code and trying to print some output and reproduce the error. Rather use a debugger, and this is fairly easy here on the left. You can just add breakpoints, you can remove them, you can have conditional breakpoints if you wish, and then you can step over functions, you can execute this code line by line, and important just that you run it in the debug mode. But this exists in other languages as well, like Java or C++. But here it's also fairly easy in this IDE. Any questions about Python? Yes?
The line that I'm putting in will execute as well.
It will stop before running that line. So we see I'm putting...
Before.
It just stops at that line before running it, because what you see is, if I'm running it, it just stops here, but A is not yet in my variable overview, but rather I say we step over and then it's done. So now it's run this red line, but the blue line has not been executed yet. And it's the same with the breakpoint. Since we still have a little bit of time, I will then talk already about the coursework. So I don't need to talk about this later in the lecture. So in this course, we have a lecture which is 90 minutes per week, but we also have this lab session 90 minutes per week, but we have 4 lab sessions on Fridays because we have about 200 students taking this course, which I'm very happy about. But 1 lab session would not be enough because you may have lots of questions. That's why we have 4 of them. And you can come to any lab session that you want. You don't need to come to the lab sessions if you have other stuff to do on Friday. You can join via Zoom, so I can also help you with your questions via Zoom. But you're encouraged to come to at least 1 lab session, sit together with your fellow students, and work on the coursework. And for the coursework, it's the following thing. There's exactly 1 mandatory problem in this sheet. So this sheet is 10 pages with lots of really cool assignments that will keep you busy during the term. There's 1 mandatory problem, and you need to do and pass this mandatory problem. Otherwise, you will not be able to sit the written exam. So this is in German, we call this Leistungsnachweis or Übungsleistung, if you read this maybe in your study regulations. This is something you need to pass in order to sit the exam. If you pass this mandatory problem, but you fail the exam, then you just need to sit the exam again. You don't need to do this mandatory problem again. So it's 2 separate examinations. And there's exactly 1 problem in here that is your mandatory problem, and it's about an exercise. It's written exercise P minus 13.50. Such references like P minus whatever always refers to the Goodrich book. So you definitely need access to the Goodrich book. And in the Goodrich book, there is a problem about pattern matching algorithms. Pattern matching algorithms are a topic we don't discuss in the lecture, but you need to read this in the book. It's a few pages and then implement these algorithms. So that means you can get started very quickly with the mandatory problem once you're a little bit familiar with coding, maybe with the theory of the first 3 weeks of lectures. Then you could start straight ahead with the pattern matching algorithms. So it's independent from the lecture, so there's enough time for you to do it. Because some professors, they have mandatory problems that you just have time to work on in the last week of the term because they require you to take all the lectures, but then you don't have time left. So here's enough time left. And you need to look into this problem and see what the Goodrich book requires you to do. And you need to implement these algorithms. And you need to create a Jupyter notebook. So Jupyter notebooks are like these IPython sessions, but they run in the browser. It's fairly easy to set up. There's also a reference here to Jupyter. And you need to, in your Jupyter notebook, implement these, I think it's three pattern matching algorithms and write a report. You can write a report directly in the Jupyter notebook in which you would first describe what the problem of pattern matching is. You would briefly describe how these 3 algorithms work. So it's 3 different algorithms for the same problem, but they have their own pros and cons. And you would then run these pattern matching algorithms on some text documents of your choice. You can use any text documents that you want and find any patterns that you want. And some algorithms are faster than the others, depending on the size of the input, the complexity of the input, and the pattern. So you would run some experiments and compare how these algorithms run and which ones take longer, which ones take shorter. And you would describe this in your report and write a quick conclusions. It's typically a few pages, this report. It's not too much. And the good news is you can work with your fellow students on this. So groups of up to 4 students are possible. And you will make one joint submission. So one of you will make a submission via iLearn. The submission portal in iLearn, I think, is already open for the mandatory problem. And the deadline is July the 1st. So there's enough time left. And make sure that your submission includes all your names and your student ID numbers, because I only see the student ID numbers when I add your mark in Primus. The mandatory problem will not have a concrete mark. It's just a pass or a fail. There is another problem. It's an exam bonus problem. This is problem 12.6. It's in this sheet later. We will look at it in a moment. And if you do the exam bonus problem, this carries a 10% bonus for the exam. I will talk in the lecture today about exams, and in my exams, you can get up to 50 points. That means if you have the bonus, you get 5 points on top. So if you have, 40 points in the exam, you get 5 points on top if you have that bonus. And you can do this bonus problem. It's optional, obviously, until July the 1st. Again, with a team of up to 4 students. And what is problem 12.6? It's implementing a decision tree learning algorithm. But this is something we will discuss in 2 months. So it's far away from now. It doesn't matter for now. Because we will study trees as an actual data structure, but we will do a link to AI, to machine learning, and we will see what you concretely need these trees actually for in AI as one example. And we will discuss this algorithm in, 2.5 months. And once we have discussed it, you can work on this exam bonus problem. So it's nothing that matters for now. And for the coursework, you can use any programming language that you want. If you want to use Java or C++ in the coursework, I'm fine. But you should use Python because it will be easier. And we are studying Python in this course. And in the written exam, there may be some coding problems in which I expect you to use Python on a piece of paper. So use Python. There are also some good news. Everyone is talking about generative AI and ChatGPT, and a lot of professors try to ban it. In my courses, so for your coursework, you're not only allowed to use Gen AI, but I even expect you to use these tools. because they will help you to grow. This is now the state of the art, and if you don't use it, you are not state of the art. Still, you need to know how these algorithms work. But if you have some algorithm problem, you could maybe ask ChatGPT for a proposal. You could try to study that proposal, improve it, or maybe you have your algorithm that doesn't work, and ChatGPT or any other AI tool could try to improve it for you. And you are welcome to use ChatGPT also for this report of the mandatory problem or any other AI tools, but there are some rules. So you have to critically assess what these tools generate. You may need to add references. You may need to extend or improve these outputs. And I also want you to explain in your report which AI tools you have used and why and for what. And these are the same rules if students do their bachelor's or master's thesis with me. You're not only allowed to use these tools, but I expect you to use these tools because others are using them too. And if you don't use them, you won't be competitive. But use them smart, so human intelligence first and then artificial intelligence, not the other way around. So these are my rules, and we have just started with Python. So problem 6.1 is what we just did. Familiarize yourself with the intro to Python file. And obviously, you're supposed to look into this whole file. There's, for example, the while loop and a few more little things in it. Do these extra readings I just mentioned. And make sure you're familiar with Python IDEs like PyCharm or Visual Studio. Work with this interactive mode. And then there are a couple of more exercises from the book in Goodrich, like R11 to R111 and so forth. So before there was a reference with a P, because this is a project in a Goodrich book, and these C's, they are just smaller, or R's are just smaller exercises, and C's as well. Take a look at them in the Goodrich book. If you feel you're already strong in Python, feel free to skip section 6. If you're new to Python, definitely work on this just to get some more practice in Python. And then as we advance in this course, today in the lecture, we will start looking into graphs, which we continue next week in the lecture. We will do complexity analysis probably next week or in 2 weeks' time. There are lots of problems for you, and you're supposed to do all of them, but they're all optional, so it's your choice. And I'm here on Fridays if you have any questions on the lab problems, be it the mandatory, the bonus problem, or all the other problems, or any questions you may have. I'm available also in German, obviously, if you want to ask questions. And we have all of this available. We also have my teaching assistant for the tutorial sessions, but I'll say more about this later in the lecture. And something you may notice if you look into past exams, because I notice there are quite a lot of students who don't do all of these problems in this coursework sheet. And sometimes I just copy one of those problems as is in the exam, and I can notice directly who did their coursework and who did not. So you're expected to do all the coursework because it just gives you more practice, because the lecture is there for an inspiration, for initial content, and then you need practice. And for this, so I'm not expecting in the exam that you, for example, know what the solution of problem 14.2 is, but solving problem 14.2, when you look at it for the first time, is maybe a bit time consuming. And if you have extra practice from these lab sessions and such a problem appeared by chance in the exam, doing it in the exam would take you 2 minutes. If you do it for the first time, it's feasible. Without doing the lab problem, it just takes longer. That's why do all the coursework problems. It will make your life much easier. And in combination with the bonus problem, overall, I see lots of students every year who got a 1.0, the best mark possible. We obviously have fails, but if you study for this course well, do the coursework, go to the tutorial sessions, it's probably quite difficult to fail the course. So, because there is lots of opportunities to practice. Are there any questions about this lab session or Python? Yes?
Sessions on the afternoon that are 2 sessions, are they going to cover the same thing if you want to attend one of them?
Yeah, all the lab sessions are the same. So I don't present new content in the lab sessions. Rather, I'm here to help you with your lab problems. So if you come in the morning or the afternoon, or if you come to all 4 sessions, or you don't come to any, it's up to you. There's no new content. The content is only in the afternoon lecture. Yes? Yes. No, so they are just to get some practice about what we talk. Sometimes, obviously, it's maybe a little bit more content or an application of an algorithm to something. All the coursework is recommended. But it's all associated to the lecture in some way. But maybe just see how the lecture goes and then look into the coursework. There was a question here in Zoom that I quickly want to address. Where you find the coursework PDF in the Nextcloud directory, where you also find the slides and all the other stuff. Any other question? Well, then we are done with the lab session today, and I'll see you in the online lecture at I think 3:45 or something like this, which will also be recorded. Take care.